Good day. Today we can discuss the problem as like find the deflection at the center of a simply supported beam of span length L subjected to uniformly distributed load throughout its length, which is L. We can find the deflection through finite element analysis method with the aid of point collocation, subdomain method and least squares method, finally Galerkin's method. In that, first we have to see about point collocation method. In point collocation method, we should identify the residual. So first we should identify the residual from the given problem. For the reason, I may convert this sketch it into free body diagram. Likewise, okay, in A point the upward force is available, in B point also the upward force available. The distance between those points is L, and always in a finite element analysis the load is centric. So I consider load acted on C point, which is which has the distance from A point is L by 2. So these are all the things and assumptions we should made earlier to solve this problem. Here, what is the governing equation of a beam? The governing equation of the beam is the EI into d power 4y divided by dx power 4 minus w is equal to 0. Within the limits of 0 less than or equal to x less than or equal to L. Likewise here, okay, the problem has 0 as the lowest boundary and small l is the maximum boundary, so that I wrote here 0 less than or equal to x less than or equal to L as the boundary condition. Here what is E? E is the Young's modulus and I is the moment of inertia. So from this data we can frame the governing equation. So what is the trial function for deflection problem? Initially we should assume the trial function for solving the problem deflection. This is the deflection, okay. So the trial function we can assume as like y is equal to a into sine pi x by L. I consider which is the trial function for solving the problem. In our equation there is d power 4y by dx power 4 which is available. So now how do I identify the residual? Yes, I have to go to differentiate the trial function it into 4 times, because the main differential equation of the problem has 4th order, so that I have to differentiate this trial function it into 4 times. So how do I do? Yes, first I differentiate dy by dx, which is equal to what happens, the sin phi x L. If I differentiate sin phi x by L, sin ax can be solved with the a into cos ax, which is the formula for differentiation formula for sin ax. Here we are having sin pi x by L. What happens? Yes, here a into, here what is the a term? Pi L. So that a into pi L. What happens? Sin is cos pi x by L. After that we can't complete this level because we are having 4th order differential equation, so that I again perform the differentiation, which is d square y by dx square. If I convert the cos, differentiate the cos with respect to x, means cos x is equal to minus sin x, which is the formula cos x dx, which is equal to minus sin x. So what happens here? Yes, here minus symbol I introduced. After that a, what happens, pi by l, again I differentiate, so here pi by l into pi by l into sine pi x by l, so which can be written as like minus a pi square divided by l square into sine pi x by l. After that, this is also not enough, so that I again differentiate d cube y by dx cube. From this, what happens, minus a, here again I perform the differentiation of sine pi with respect to x, means here I got pi cube by l cube into sine. Differentiator means it may be converted into cos pi x divided by l. Likewise, I can get the equation. It is also not enough because our problem has fourth order, so I have moved to again differentiate the same trial function with respect to x, which can be called as d power 4 y by dx power 4, which can be written as like here again like differentiate cos, means I got cos x dx is equal to minus sin x, so this cos is converted into minus, so if I multiply that minus it into this minus, it may be plus, so here plus a, again I got pi by l, so that pi by 4 divided by l power 4 into sine pi x by l, which is the differentiation level of the given trial function. Why I did? Yes, for getting the residual of given differential equation, I perform the differentiation of trial function with the fourth order. Now we can move to next step, which step is identifying the residual. How do I identify the residual? Let's see. Here we can substitute the identified d power 4 y by dx 4. Here in previous step I identified d power 4 y by dx power 4 is equal to plus a pi power 4 divided by l power 4 sine pi x by l I got. Now I can substitute that equation it into the given differential problem. Here what I have, yes, ei into d power 4 y by dx power 4 minus w is equal to 0, which is the governing equation. So I can substitute d power 4 y by dx power 4 in the corresponding equation, so that I can get here ei into d power 4 y by dx power 4 I found here. So a into pi power 4 divided by l power 4 into sine pi x by l minus w is equal to 0. So which is called as residual. So this form, which is known as residual. So the residual r is equal to 0 for all the problems. So which can be written as like r is equal to ei into a pi power 4 divided by l power 4 into sine pi x by l minus w is equal to 0, which is the residual identification method from the given problem. After that, this problem can be solved by point collocation method. Yes, I'll show you how do you solve this problem with the point collocation method. Now I move to solve this problem with the point collocation method. Here, how do I solve the problem with the point collocation method? First, in previous step I found residual r is equal to ei After that, A into pi power 4 divided by L power 4 into sine pi x by L minus W is equal to 0. Likewise, I solved the residual from the previous step. So now what I can do with this, so to get the deflection at a point x equal to L by 2, because in our problem the maximum deflection occurs at the center of the beam. The center of the beam has the distance of L by 2. So the maximum deflection occurs at the center of the beam. So how do I get, I can rewrite this same residual equation it into E I A into pi power 4 divided by L power 4 into sine pi x by L is equal to W. Likewise, I can write. After that, where the maximum deflection occurs at L is equal to, x is equal to L by 2. In this area, maximum deflection occurs. So I can substitute this L by 2 on x, which is residual formula. So that EI into A into pi power 4 divided by L power 4 into sine pi by L. What is x? X is L by 2, because maximum deflection occurs at the mid of the beam, which is equal to W. So what is sine pi by L into L by 2 happens? I can cancel the L because the denominator and the numerator is same L, so that I cancelled. From this I can get sine pi by 2. Okay, here what happens? Sine pi by 2 is equal to 1. So what happens here? EI into A into pi power 4 divided by L power 4. Here the sine pi by 2 term, which is 1. So that here 1 is equal to W. So I can rewrite the term A is equal to, here what happens, what can I identify in trial function, that is A available, so that I should identify the parameter. The parameter is A. So I should find out the parameter A value is equal to W. L power 4 goes up, so that W L power 4 divided by pi power 4. After that E I. Likewise, I can rewrite the A parameter equation. So A parameter is looking like W into L power 4 divided by pi power 4 into E into I. Now, what is the next step in point collocation method? I found the A value. Now I can substitute this value into our trial function. What is our trial function? Yes, we can see our trial function is y. Trial function is y is equal to A sine pi x by L. If I substitute A, what happens? Because I identify A parameter value, the A parameter value is W L power 4 divided by pi power 4 EI. So here if I substitute W L power 4 divided by pi power 4 EI into sine pi x by L. So where the maximum deflection occurs, which is the next step. Here you see, according to this diagram, the maximum deflection occurs at the center of the beam, which is L by 2 location. So what happens? Next step, we have to identify the Y max, where the maximum deflection occurs at the point of x equal to L by 2. So I can substitute the x equal to L by 2 in this trial function. From this we may get the solution of the problem. Here what happens, W L power 4 divided by pi power 4 EI into sine pi into pi L into what is x, L by 2, x equal to L by 2, because the maximum deflection occurs at the location of L by 2 area, so that L by 2. Now I can remove the L term from the area. So what happens, this equation can be written as W L power 4 divided by pi power 4 EI into sine pi by 2. What is sine pi by 2? What is sine pi by 2? Sine pi by 2 is equal to 1. So you can write W L power 4 divided by pi power 4 into EI, which is the formula for identifying the Y maximum. Now we can write Y maximum is equal to W L power 4. The pi 3.17 power 4 is equal to 97.4. So I can write here 97.4 EI. So from the point collocation method I got the solution. Y max is equal to W L power 4 divided by 97.4 EI, which is the maximum deflection occurred point according to point collocation method. Next I can move to identify the maximum deflection of the beam with the subdomain collocation method. What happens? Let's see. The second one is the second subdomain collocation method. In that, what is the formula? Yes, the formula for subdomain collocation method is I is equal to integral of 0 to L or dx is equal to 0. So what is R? In previous step I found R is equal to A EI pi power 4 divided by L power 4 into sine pi x by L minus W into dx is equal to 0. Likewise I got. Now I may substitute this R value into our subdomain collocation common form. From this we can get 0 to L. R value is AEI pi power 4 divided by L power 4 into sine pi x by L minus W into dx is equal to 0. Here what is next step? We can find the integral of these terms, because we are having the limits 0 to L. How do I identify the integrals? Let's see. Here 0 to L AEI pi power 4 L power 4 is available. So which are the constant term I can take outside AEI pi power 4 divided by L power 4. What happens with the sine pi x L? The sine pi x by L, which can be differentiated and rewrite as like minus cos pi x by L divided by pi by L, which is the formula for sin pi x by L integration. Now I can write here minus cos pi x by L whole divided by pi by L. What happens with the minus W with respect to dx means I can get minus wx. What are all the limits? 0 to L, which is equal to 0. I got. After that, what happens with the next step? The again AEI pi power 4 divided by L power 4 I got. In that if I substitute the values, I can move this pi by L as like L by pi in numerator side, so that I can write minus cos pi x by L into L by pi. I make the reciprocal of the equation, so L by pi minus w x which has the limits of 0 to L is equal to 0. Now I may move to next step. Here you see L available. What happens here? I can cancel the L power 4 here, L cube, pi here available, pi here cancel, pi cube, so that this equation which can be written as like AEI, after that pi cube divided by L cube of minus cos pi x by L, cos pi xl minus w x is equal to 0. Next what happens? Here the limits are 0 to L. So what happens? Yes, in that I can write. Now I can erase the above steps. Now what happens? Let's see. 1 minute. Let's see. Yes. Now I can write the formula. What I found here is EI pi cube by L cube into minus cos pi x by L into L into pi minus wx. I got. I removed the term. So from this pi x by L minus w I got. What happens here? Is equal to, here you see AEI, what I got here, pi cube by L cube, so that I can rewrite pi cube by L cube. So now if I substitute the upper limits, which is cos pi, here x by L available, x in the place of x I can substitute L divided by L. In previous step, here you see minus available, so that minus can be taken commonly outside. So here also I can present the minus. Okay, so this minus is get out from this overall term, so that minus AEI pi cube L cube I got cos pi L by L minus, if I substitute 0 here means cos 0, I got cos 0 minus, what happens? I substitute the upper limit in the wx means WL I got minus 0. If I substitute the lower limit 0 means here I got 0, which are is equal to 0. Likewise I may get the form. Here now I again goes to simplify, which is minus AEI pi cube by L cube, and then what is cos pi? Cos pi is equal to minus 1. What is cos 0? Cos 0 is 1, so minus 1 minus 1. After that what happens with the minus WL? I can move to right hand side, so that plus WL I got. Okay, here cos pi is equal to minus 1, cos 0 is equal to 1. I substituted here. After that here I got minus 2. Already here minus available, so that this term is 2. I got 2 AEI pi cube by L cube, which is equal to WL. Here I have to have identify the A term. For the reason A is equal to WL here available L cube. If I cross multiply L into L cube, I got W into L power 4 divided by what happens other terms, which is 2. Here first I get 2, after that pi cube, after that e into I. Likewise I may get the term downward. So WL power 4 divided by 2 pi cube EI I got as a A. What is our next step? I substitute this identified parameter A value into trial function. So what happens? Let's see. Our trial function is y is equal to, our trial function is y is our trial function is y equal to a into sine pi x by L. Here I found the a value as like a is equal to WL power 4 divided by 2 pi cube EI. Likewise I got in our previous step. This 2 pi cube can be simplified again. So this A value is substituted on this trial function. I may get y is equal to WL power 4 divided by 2 pi cube EI into sine pi x by L. Here I simplify the pi cube value by with the aid of calculator. I can convert WL power 4 divided by 62 EI. After that the sine pi x by L. According to our problem, where the maximum deflection occurs, the maximum deflection occurs at L by 2. So we can identify the y maximum is equal to occurs at x equal to L by 2. So what happens? I can substitute the term L by 2 in x. So WL power 4 divided by 62 EI into sine pi L into L by 2. What happens here? I can cancel the L, the term from the both side, and sine pi by 2 which is equal to 1. The simplification terms I got. So y maximum is equal to WL power 4 divided by 62 EI into 1. So the y maximum occurs at WL power 4 divided by 62 EI, which is the answer I got from subdomain collocation method of finite element analysis with the deflection problem.